Hi, welcome to the 10th video in the Python Millionaire Retirement Simulator series. This hopefully will be the last tutorial, which means we're going to cover a lot of ground. But to do that, we need to cover a lot of things. First of all, here's our plot where we last left it. And it looks okay. We're not using this square, and I probably won't even get to that. But the things I will get to are this. We see that we have some formatting issues where some of our dates are overlapping or overlapping with other plots. And we're going to add some features so that we can show retirement options for different, if we stay employed more for a longer amount of time. So some things will be related to formatting, some things will be related to the simulation itself. But in the end, we should have a tidy display that we can go on to further, customize to your own situation. And I'll make some suggestions about those customizations without necessarily doing them in this tutorial series. Well, to get started, I want to start with the formatting issues. Okay, I'm not a big fan of this, and so there's several ways that we can figure or fix this. Some of them, again, will be custom to my screen and what part of my screen that I'm sharing. And so you should customize them to your own liking. But with that said, what I will give you will be some good guidelines. So this is where we left off, and what we want to see is these dates here are overlapping with each other in an unpleasant way, and these numbers are overlapping with here. So let's try to fix that. So one of the first things we might do is we would go to where our figure was first created, right here on my code. It's on line 77, and we can just add after this, giving it that we want 2 by 2 plots. We can say fig size equals, and the dimensions that have worked for me are 9.5 comma. I'm sorry. Let's see, 9.5. Or 9 comma 4.5. Sorry, confusing myself here. And so just with that change, let's try running it again. And now we see, okay, it's a much nicer plot. Some of these things aren't overlapping so much over here. These are still hard to read, so we're going to do some more to fix those. But this fits better on the screen. So again, you want to take some time and make your plot look pretty. I'm going to try my best to kill this, and it's not going to be, well, good. It's easier than I thought. Okay. So that's done. The next thing we'll want to look at will be down where we make the plot. So we'll have to scroll down to about here, line 137, where we say if the sim is, the 10th simulation in a series, then we'll plot it. So we'll have a lot to add there, and the reason being is that when we add stuff there, we're going to want to rotate the x-axis labels so that they're at an angle, and even make them a little nicer by adding a month and a day, something that's easy to read, easy to understand. To do that, we're going to need to import something at the top. So in fact, I said to go here, but let's go back up to the top. And under matplot, under this import right here, we want to import something called mdates. And so, let's see, under here we'll say import matplotlib.dates as mdates. Okay, so that'll be important to have. And then we'll go back down to line 137-ish. There we are. And we'll need to add a few things down here now. So I'm just trying to check my notes here. All right. So the first thing we'll do is we need to, and I found a lot of this out through trial and error. We need to determine, or we need to make sure that the code, as it's running, understands what plot we want it to perform a function in. Sometimes, since it creates them in 1, 2, 3, 4, it will the fourth plot will be the active one, and so when you tell it to do something, if you don't specifically tell it which plot to do it to, it says, oh well, the fourth was the last one you made, so I'll do it to that one. to get around that, we're going to make this new designation where we say ax equals axs 0, 1. So we've defined an axis that's equal to the axis we want it to work on. And that apparently is a trick that allows us to give the commands we're about to give to the proper plot. Okay. After that, we'll say ax dot x axis dot set underscore major underscore formatter. And then in the parentheses, mdates dot, that's where we're using the mdates we imported, date formatter. And inside this parentheses, we're going to put, well, we need a quotation first, and we'll put percent lowercase b space percent uppercase y. What this will do, it'll be a month abbreviation and a full year. That's what those dates mean. And now we do the tricky bit. Now, if you think that I'm some kind of Python genius, I'm not really. All this stuff came about by using, the Python genius's best friend, which is the internet. So I had to look up several different things by a series of, how do I change figure size, and not to write out all the dates on matplotlib, and how to adjust the tick frequency. So I did a series of searches that I'm condensing now for this tutorial series, just to make it not a 200-hour tutorial. And so in the process of doing that, I came up with these solutions. I don't have all this stored in my brain for all time. So for label in ax.get underscore xtick labels, which equal major colon. All right, so we have a for loop going there. Inside the for loop, we'll say label dot set rotation equal 30. So we're going to rotate our axis by 30 degrees, and then a new keyword horizontal. I have to spell it right. Alignment, all one word, equals right. Okay. So again, I found those in internet searches, but that should adjust our labels now. Now we will want to adjust some of the what's called the W space and the H space. I think of it as width space and height space, meaning the space in between the plots. That will prevent any overlap. And so I found some, I think that they work pretty well. We're going to say plot plt dot subplots underscore adjust W space equal 0.32, comma, H space equal 0.42. Again, those are numbers that work for me. If you follow this exactly and your plot doesn't show up the way you want, you can tweak these adjustments yourself. And that's the whole point of learning programming. And then finally we'll say, instead of saying this AXS01, we'll just change this to AX since we redefined it. And that should be it. Okay. So we want to kind of save this change and just see that it worked the way we hoped that it did. So let us rerun our simulator. Oh, and we have a problem. We misspelled label, which I misspell it so often, I recognized it right away. Label. Oops. You gotta put your thing in the right spot. Now, is label spelled right everywhere else? I think so. If it's not, we'll find out. Okay, so here's our plot now. And you can see that we have January 2022, January 2023. One thing that I struggled with for a long time, and I'll move this over so my face is not in the way. I struggled with getting the number of tick marks down here to be a good number for the plot I was doing. And what ended up happening was that by trying to force it to be a certain number, I was actually making it worse, and that the automatic thing that Python wanted to do worked out better, best of all. So sometimes you just got to get out of your own way. Okay, so this is a much more pleasant looking plot, and I don't have any other complaints to go on right here. So now we're going to go to the idea of, now that our plot looks good, we're going to make sure, we're going to do the simulator again. But instead of retiring in 2030, what if we retired in 2040 or 2035? And that's what we want to investigate. And we're going to do so in a way, again, that I hope would be make our plots look pleasant and kind of easy to understand. So the main crux of what we're going to do is you have all this stuff going on, right? And I'm going to highlight it up to about here, where after we've picked our retirement date, then we enter this for loop, and then we enter the while loop, and we run around through all that for a while, and then we finally get out of all that, and we do some averaging that we, and some picking out the final amounts, and then doing those plots. So all that is the simulation. And if we wanted to, we could make a definition and have just a one-line simulation. Instead of doing all that, we're just going to create a set of retirement dates, and then since retirement date is the variable, we'll use that to our advantage. So let's set up some retirement dates. Underscore dates equals. We'll make a list. And with lists, you can open them and then close them on a different line, and that's kind of convenient. We'll just pick this same date, and we'll put a comma after it, and then we'll make copies of it. So let's pick 3 dates, and we'll just change the years. Now, one thing I want to do is, in fact, again, I figured this out from trial and error. I'm going to put the latest date first, and then subsequently move to earlier dates, so that the last date in our simulation will be the one that we originally used. For plotting purposes, that'll end up making the plots work out much nicer. We're going to define some colors now to go along with each of these retirement dates so that everything is color-coded. Colors equals, and we'll just say red, green, blue. You got to put those in quotes though. Red, comma, green, comma, blue. Could be single quotes, could be double quotes. They have to have a comma between them. So we have 3 colors and 3 retirement dates. And now we're going to make a loop. And in this loop, we're going to zip 2 things together. If you've not done this before, it's a clever thing to, when you have 2 lists of the same size, it's nice to use this to zip them together. One thing you should be aware of with zipping is that I think the default behavior is to do its best to zip even if the lists aren't the same length. So if you have one list that had 10 things and one list that had 3 and you zip them together, it'll just take the first 3 things from the long list and zip it with the things from the short list. And that might not be what you want to happen. But in this case, we know we have 2 lists, each have 3 things. So for call, comma, retirement underscore date in zip colors, comma, retirement dates, colon. Okay, so that's spelled the same. Retirement date is spelled the same as we use it in here. And then we'll have this variable color, or call, from our colors that we can use. So now, if you're in Notepad++, you can just select all of this text, all except for the very last plot.show, hit tab, and now everything is inside this for loop that we just made, which is pretty nice. I like it. And then I think everything else works exactly how we want it to work already. So the only thing we want to do is we want to take advantage of this color that we added. So if we copy this variable and we go down to where we're making a plot, well, there will be 2 things we change. We'll add it here so that all of the plots for a certain retirement date will be the same color. Color equal call. All right, that's all we have to add to that. We're going to delete this plot.pause, and we'll put it down here at the bottom. So I just cut it from there. So we're gonna wait till the very end to do our plotting, and that should make everything run faster. And in fact, if you wanted to make it run even faster, you can change this number from 10 to 100 so that it's not doing as many plotting functions. Now we want to use the color again. I go back and forth with this because I like having the black dashed line to show the average value, but it makes a little more sense to plot it with the same color and for the color to show up as in the legend. Now, one way you could get around this would be to take this entire thing after the fact, copy it, and get rid of the label, and then change this color back to K. K is the color for black. So this would just make the same plot again, dates and average amount with the line width and the color style. You plot it afterwards in black without using a label. And that may, in fact, trick it to put the black line, but then label it with the color that we want to see. I haven't tested that yet, so I hope that works. And then here for the final amounts, we want to use the same color.equals col late, so we can just stick that in there. And so then our final histograms will also color code match everything we've done so far. We're gonna run this to make sure it works, but then we're gonna add one last nuance, and you'll see why after we run this one. So let us run it and make sure that we have no errors. So far so good. We'll move this up here. Okay. So you see, yeah, that plotted much more quickly, and now we have this nice color coding going on where retirement 2040 is in red, retirement 2035 is in green, retirement 2030 is in blue, and you can see the black line here at the very end. Did plot, in fact. And in fact, there's 3 lines plotted. If we were to very carefully zoom in right here where the changeover is, you can see that, in fact, there was a black line plotted for the one and a black line plotted for the other. And the reason they're not exactly the same is just from statistical differences, but the reason that they're very similar is because the ensemble of all of the things should converge on a average that's pretty fixed if you did enough simulations. Now what's happening over here is that we have a bunch of histograms, but the histograms have different bin widths, and so that's not as useful to us as a histogram that have equal bin widths. And so we'll want to fix our bin widths for these particular histograms so that when we plot them, they make sense to us. So that's the last change we're going to do. And to do that, we're right in the area we want to be in. So we need to we'll need to add our own binning, and to do that, we're going to use something from the NumPy library called linspace. So up here somewhere, you can do it. I think we only need to use it down here. So we could do it down here. Inside the loop, we'll say my_bins equals MP for NumPy, linspace, not line space, linspace. It's a linear spacing routine in NumPy. And you give it a start number, a stop number, and a step size. So we'll start with 5 e to the 4, 50,000, comma. We'll go to 8 e to the 5, and we'll step in steps of 200. Or this will be not the step size, rather, but the number of steps. So we'll have 200 steps. And these will be linearly spaced bins that we want to use. So to use them, we go inside of our definition for where we're calling for this histogram here, right there. And somewhere after maybe histype dots, or before final amounts, in fact, we should say bins equal my_bins, comma. And I'm not sure this is entirely necessary, but I've been adding it. So we'll say range equals, and it's looking for open close parenthesis. Inside the parenthesis, I copy these 2 numbers. Oh, that did not work. Copy, paste. Okay. So that is our thing. Now, because it ran so fast, I'm going to up the number of simulations also to 3,000. So we should get a lot more statistics, and that should make our histograms fill out a little bit better. Okay, So with all those minor changes there added, we now have a pretty, I'm pretty excited to see what our result will be. So let us run our retirement simulator one last time. Never say last time, right? All right, here it is. Let's move it up so that you can see everything going on. Okay, well, it's finished. It didn't take very long. And so you can see now we have our 3 sets of simulations that are color-coded, and we have our 3 sets of final results that are also color-coded. And you know, some things that kind of show up to me on the screen here are, when we look at this plot, you can see that when you retire earlier, it's kind of squished in terms of the number of results you get. As you move out to a later retirement date, that widens out to a larger distribution of outcomes. And then, of course, in our late retirement scenario, we have some wild outcomes, including this one up here, which was just kind of an outrageous return. And we can even, if we dare, we can zoom in on some of these to see a little bit more of the curvature and some of the features going on here. But basically, yeah, this black line is following an average that's pretty consistent for each of the simulations, and that is expected. But as you move through time, you would end up with a larger variety of outcomes. Some are still low. You still have some green and red that end up doing pretty poorly, just like you do for blue. But you have a lot more outcomes that end up with a much higher average and a higher, what would you call it, most likely outcome. And so when we that's what we're showing over here, is just if you were to, we can do this moving thing, and that may or may not work. If you were to just look at the last numbers here in the red, or the last numbers in green, the last numbers in blue, that's what we've put in the histogram bins over here. And what we're seeing now that these are all binned on the same footing is that in our early retirement scenario, the most likely, the most likely numbers we end up with are on the lower end range, right? This cutoff here is based on the range that we set and the bins we set. So stuff that fell under that was, put in this very bottom bin. But up here, this is our most likely scenario where we end up with, a pretty low and modest amount of money. Here in the retirement 2035 scenario, not the maximum, but the most likely value has shifted to the right, so that it's now at a better, a better retirement solution kind of idea. And then again, if you work longer up to 2040, that most likely scenario has broadened out, and it's somewhere around here. You would say it would be, if you were to fit this with a line, you'd say it maxes out, somewhere around here. Now again, we're seeing similar issues now with some overlap on this x-axis, and since I've showed you how to deal with that, you can deal with that yourself. In fact, what the heck? Why don't we deal with it now? So the easiest way to deal with that would be to take what we had and copy it. We don't need to do the subplot adjustment because that actually adjusts all the subplots. And we go down here to this guy, and we'll copy it in here, and then we'll see what we need to change. So I'm going to Shift Tab this back over. So we want to be dealing with the correct axis. So this is the axis we're interested in now. So we'll copy that, and we'll say X is equal to axis 1, 0 now. And then we don't need a date format, so we can just totally get rid of that. But we can still say for label in ax.getXTickLabels, set the alignment and rotation, and then over here ax.hist and ax.legend. So let us run that and see what we get. All right. I wish this would move up faster. Well, there it is. And now these labels have been rotated so they're not overlapping with each other. They're sensible to read enough. So this was 200,000, 400,000, 600,000, 800,000. And you can see, you know, this is a sample of all these scenarios. So we've got this basic retirement simulator in place. And we've used it now to show different retirement dates and what kind of outcomes we get. Another approach that you could take, which I have not taken, but I would just leave it for you as homework if you want to do, would be that instead of up here where we're saying while today's date is less than retirement date, this while loop could also be while retirement is less than $1 million. And at that point, you can figure out what retirement date you would get based on shooting for a retirement money goal rather than a retirement date goal, right? So, I mean, I could do that right now. I don't know. It's not set up to do that because it's going to loop through retirement dates. And so we could set it up to loop through instead of final amounts. So why don't we do that? Just because I'm being crazy. I'm doing stuff. I'm going off script here, everybody. All right, let's say retirement underscore amounts. And we'll make that a list. And since we'll try to pick the stuff that's on the thing, so something that's easy to hit, we'll say 100,000. I'll make copies of that, and then we'll go to 400,000 and 800,000. Okay. So, is this going to work? Are we going to be set up for this? I have no idea. So now we want to loop through for colors and retirement amounts, and colors and let's see, final retirement. All right. So colors, retirement amounts, colors, final retirement. So now we need to use final retirement somewhere instead of retirement date. So here's the last place we use retirement date. So now we can just say while here, I'm going to do this. I'm going to make a copy of this to keep that old architecture there. We'll say while retirement is less than final retirement. And we need to define retirement is, well, it's already defined. It's amount I already have. Okay, so while it's less than final retirement, it's going to continue to do this same looping and plotting. And who knows what it's going to look like, but let's see what happens now. Oh my gosh. I can barely wait. Okay, name, final retirement. It's not defined. Right, because I'm an idiot. Retirement amounts should be there, and final retirement should be there. Okay. So, happens to the best of us, y'all. All right, well, it's going to do something. Okay. Well, I didn't anticipate this, but there are something ends up having a different shape, and so we can't do all of the plotting that we were doing formerly. And you know, that's the kind of thing that happens. So, I mean, we can just we can take this final amounts deal down here and totally get rid of that for the moment and see if everything else will plot, because I expect that everything else would still work. And if you didn't see what I did there, I can show you. So now you can see that the first amount was hitting a certain date, just like we were stopping at a fixed point in time before. Now we're stopping at a fixed amount, and that you have this big spread of dates. So here's someone who had to work to January 2080, but eventually they hit their retirement goal, even though they came really close to it over here, and then it dropped way back down, which seems like a bad strategy to me. And because I went in ascending order, the blue is showing over the green, and so if I reversed it so that the 800,000 was first, then it would be different. But what would happen now is that you'd actually want to plot a histogram of your dates rather than of your amounts. Your histogram of your amounts would be a single value because all their final amount values have now been consolidated into a single value, right? Duh. So now if you plotted a histogram of the dates, it would show you the most likely date that it would take to get you to that retirement goal amount. So it's kind of flipping the simulation on its head a little bit. And you can see everything there. Okay. Well, I hope you have enjoyed this. Now, if you wanted to add your own little nuances to this, I will give you a few suggestions. One is you have this part of your simulation here where you go into, you check to see if you've entered into a new year. So every time you've entered into a new year, hopefully you're not making the same amount of money you were before, right? So we have a salary, right? Somewhere, paycheck interest rate, current salary. Here we go. So this current salary is $50,000, but maybe you get a 2% raise every year. And since your paycheck is part of your salary, and what you're adding to retirement in this case was 10% of one paycheck, if you copied all of this and put it down into your loop, you can now give yourself a raise, a modest raise every year to make your simulation more realistic. And if you wanted to, change the amount and you add to retirement so that, maybe at a certain level you're adding 15% to retirement, or whatever the number may be, you could make those changes on an annual basis. You could increase the amount you add to retirement by a little bit. I think changing the salary and changing what you add to retirement is through your salary and your paycheck percentage is a more likely scenario. But that's one thing you could do. You could also, you could have I've constructed one in the past that I put in my kids' ages. And then when my kids' ages were within a range that I called college ages, then I would take money out of my retirement account to contribute to a college a semester for each kid. And so if I had 2 kids in college, it would take that amount out twice, and so on and so forth. And so the idea there was just to try to make a personal and realistic scenario that moves money around in the way that I might move money around because you can take money out of your retirement account to contribute to anything you want for most things, and some things you can contribute without penalties. So, but again, I'm not a retirement guy or an investor guy. That's all up to you to figure all that stuff out. I'm just showing you how you can build something that you can use to make, some kind of fancy simulation here. And then finally, the thing you might do is that once you get to a certain year, you might think, well, instead of having my money invested in a market, which has this very broad range of interest rates, maybe as time goes on, I shrink that until, in the last days of my retirement, I'm now at I'm using a rate that's fixed, or maybe not fixed, but again, Gaussian distributed 6% returns, with a 1% sigma, meaning, basically with a 95% chance it's going to be between 4% and 8%, with a centered at 6%. That's the most likely value. And so then you have a modest positive return as you get closer to your retirement age, which is, that would be the idea of moving from more risky into safer investments as you get closer to retirement, which would avoid some of those huge swings that we saw in our simulation. Okay, this has gone on way too long, but hopefully you enjoyed this and stuck in there. And I hope you enjoyed this series. And if you yeah, check out the website, look for other things that might catch your interest, and I hope to see you in the next series.